Hello, everybody. My name is Lien. I am the mentor for this course on Introduction to Lithic Analysis with Save Cultural Heritage Group. This is the first lecture for our week 1, so we will only be covering very basic topics in this lecture, and I hope you enjoy. If you have any questions, please feel free to reach out. If you're not familiar with any of these terms, don't worry. That's what this lecture is for, is to just introduce you to them so you can begin to think about the terms and concepts a little bit more. So let's just dive in. So to start, what are lithics? This is a term that people in archaeology usually are familiar with, but if you don't have any experience in the world of archaeology, you might not know what lithics actually are. Well, the term lithics is derived from the Greek word lith, which means stone or pertaining to stone. And so when in archaeology we talk about lithics, we are talking usually about stone tools. So you'll be seeing quite often the term lithic tools, which is just the professional term for stone tool technology. Now, what are stone tools? Stone tools are pieces of worked stone that have been made intentionally. So stones typically tend to break naturally. Sorry, I had a fly. Stones tend to break naturally due to just natural weathering and other sorts of transportation and trampling processes. However, when stones are intentionally modified, that is what defines a stone tool. And to identify stone tools from ordinary rocks can be a bit difficult, especially when you are untrained. So part of this course will be to help you understand what attributes and characteristics of stone tools can be used to identify them and discern them from ordinary rocks. Now, in addition to simply identifying stone tools from natural stone, in archaeology we also analyze lithics to understand different site processes, subsistence patterning, cognitive development of early humans, and so on and so forth. So, what is lithic analysis? And by definition, lithic analysis is the study of stone artifacts from archaeological contexts. And this can include both macroscopic or large-scale and microscopic or small-scale approaches. Macroscopic analysis usually focuses on the physical attributes that you can discern with the naked eye, whereas microscopic analysis is, as it says, microscopic. So you use magnified approaches to look at the surface of these stone artifacts. And stone artifact analysis tends to include the assessment of morphology, different attributes, as well as other surface features, which we'll be getting into later on in this course. Conventional approaches to lithic analysis tend to involve usually typological classification, which we will discuss a bit later on in this lecture, as well as the study of stone tool function and aspects of technological production. And you might be wondering how this all is useful. It often lends insights into early human behavior and cognitive development, as well as perspectives on site formation processes and site function, as well as subsistence strategies. And we'll be getting into a lot of this later on in the course. Before we really delve into understanding lithics themselves, I wanted to give you a brief introduction just to the history of lithic studies and the development of the science of lithic analysis as a whole. Overall, this is a relatively recent contribution to archaeology, only about a couple hundred years old, but it is integral in understanding the antiquity of humans. One of the first scientists to really be associated with lithic artifacts was John Frere, who in Hoxne, England, located stone artifacts that were in association with extinct animal bones. And he identified that these stones were intentionally modified and that they were likely attributed to early humans. And thus, his discoveries were the first to really attribute the intense time depth to human antiquity. Later on, about 100 years later, William Henry Holmes was the first to really play around with lithics in a way that we do today by attempting his own lithic artifact analysis with systemic processes, including a chronological interpretation of stone tools. He proposed that stone tool artifacts could be used as chronological markers, which, as we know today, they in fact can be. He also attempted to understand the various processes behind stone tool production and stone tool use. After Holmes introduced the idea of stone tools as a chronological marker, this took off in the world of prehistoric studies. As we know, it's still true today, and so this concept was pretty foundational for the development of lithic studies as we know it and as we use it in archaeology. Building on that concept, Francois Borde introduced a method of classification for stone tools built off of his own experience with experimenting in stone tool production. Don Crabtree also contributed to the world of experimental lithic studies as well, offering a different perspective of the physical process related to stone tool production and how the development of varying technologies also reflects differences in cognitive development and thus differences in human evolution strategies. Also in the 1960s, Sergei Semenov introduced the concept of microscopic lithic analysis by placing stone tools under a scanning electron microscope to better assess their surface structures, which ultimately allowed him to interpret microscopic wear patterning and residue deposits related to tool use. Since then, the development of stone tool research has built on these foundational concepts into what it is today, which includes a largely technological, chronological, and typological understanding of stone artifacts, as well as traceological analysis that lends insight into the function of stone tools. Now that we've had a brief introduction into the history of lithic tool research, we can get into some of the more dense material. These terms are going to be essential in your understanding of lithic analysis, so it's going to be very important to familiarize yourself with these terms. Don't worry if it seems difficult this first time around. I know it's going to be a lot of material coming at you very fast. But we will be going over this a lot and revisiting all of these terms at different times. So this is just going to be this is the first lecture. This is just the introduction. So don't panic if these are a lot of words coming at you that you're not familiar with. The first term is artifact, which if you're familiar with archaeology, you're familiar with artifacts. An artifact is an object or specimen produced by human agency. The next term is an attribute, which is a measurable characteristic of an artifact or specimen, such as its length, color, or weight. An anvil is going to be a term that we will address for understanding of the different stone tool production methods, especially the earlier ones like the Lien and the Oldowan. But an anvil itself is a stone used as a bottom support for an objective piece that is being flaked. A blank is a detached piece that is potentially modifiable into a specific tool form. And cortex is the exterior or the natural surface of rock, be it chemically or mechanically weathered, but it's the natural surface of a rock. And objective pieces are the rock or artifact that is being modified by the removal of detached pieces, pieces of stone that have been hit, cracked, flaked, or modified in some way. And so objective pieces usually are going to be cores, nodules, and sometimes even bifaces and flakes. Detached pieces are the pieces that are removed from the objective pieces during the process of modification. And so detached pieces usually are going to be flakes, but can also be chips, spalls, blades, shatter, and debitage. All of these terms are not being covered in this lecture right now, but we'll be introducing you to these as we go along and as they become relevant to the topic of the week. Building off from the last slide, we have some more important terms that you should become familiar with. As mentioned before, a core is an objective piece. It's a nucleus or massive rock that shows signs of detached piece removal, functioning as the source for obtaining detached pieces. Flakes are a portion of rock removed from an objective piece by percussion or pressure. And so a flake is the piece, the detached piece that is removed from, say, the core or the objective piece. Debitage are detached pieces, very small detached pieces that are discarded during the reduction process. And a flake tool is a flake that has been intentionally modified by retouch or by use wear, creating a different morphology than the flake originally had. A flint napper is a term for the agent, the human agent who forms stone tool implements by controlling the fracture of the objective piece. And the process of producing stone tools is often referred to as flint knapping. So you can associate the two that way. A flint napper is flint knapping to make stone tools. A hammerstone is a rock used as a percussor to detach flakes from an objective piece. And reduction is the process of shaping an objective piece by detaching fragments. So to produce stone tools, we would have a core and a hammerstone, and we would strike the core with our hammerstone to produce a flake that could be then modified to produce a tool or used as a tool itself, just as a flake tool. And this process that I just demonstrated is a reduction sequence. Another important aspect of lithic analysis is understanding raw material. The material used for stone tool production varies by location and what is regionally available, but there are some basic requirements for the selection of material for tool production. Common materials generally include fine-grained materials such as flint, quartzite, rhyolite, obsidian, and other siliceous materials, with the most important attribute for selection being the ability of stone to fracture conchoidally, which conchoidal fracture allows for greater control and predictability when you're manipulating the stone during flint knapping. So for stone tool production, conchoidal fractures, as I mentioned before, for raw material selection is very important for producing stone tools. And a conchoidal fracture is the production of smooth convexities or concavities similar to those of a clamshell when fractured. So you can see in the image on this slide, that is what a conchoidal fracture looks like. It's kind of that discoidal, wavy, linear, semicircle fracture. And during stone tool production, another important term that you'll have to learn is the striking platform. And this is the area on an objective piece which receives the force to detach a piece from that objective material. This is the surface that you would put all of the applied pressure for detaching of a flake. This is often removed with the detached piece, so it's usually preserved on the flake itself, and will contain a platform used for the application of force. And you can use this in studying of attributes during stone tool analysis. We'll talk about this a bit more next week when we get into flake morphology. Briefly mentioned in the last slide, point of applied force is the location on a stone artifact where force has been applied to remove a flake from an objective piece. So when you're flint knapping, the point of applied force is the direct point on the objective piece or the core where you would be striking it to detach the flake. And when analyzing a flake, you will notice the bulb of percussion, which is the bulbar location on the ventral surface of a flake that was formed as a result of the Hertzian cone, which turns toward the outside of the objective piece, which is related to the flexibility and the elasticity of the material being knapped. So the swelling or bulb left on a flake just below the striking platform and point of applied force is known as the bulb of percussion. We'll be talking about this more next week as well when we go into flake morphology. But you can see an example of the bulb of percussion on the photo in this slide. As we talk more about stone tool production, another important concept is the mode in which it occurs. We'll be discussing this more next week when we go into flake morphology and different aspects of understanding stone tool production, but it's an important concept, so I just wanted to introduce it to you briefly and get you a little bit more familiar with these terms because we will continue to build on them through this course. So chain operatoire is a French term which basically just translates to operational chain, which is the order in which actions occur. This is very relevant for understanding stone tool production methods because there are specific actions which need to occur in order to produce tools specifically. And in stone tool production, another important concept is percussion flaking, which is, as we've mentioned previously, the act of using a percussor, say a hammerstone, to strike a core to produce a detached piece. So percussion flaking is using that percussor to, as the agent to remove other aspects of the stone. By definition, it's a method of striking with a percussor to detach flakes from an objective piece. And the percussor, as I mentioned before, usually a hammerstone, is the implement used to strike the objective piece for flake detachment. There are other forms of percussors as well, but for now we will stick to hammerstones, which would be known as hard hammer percussors. This is something that we'll be discussing next week as well. Now that we've had a very generalized introduction to the history of stone tools and how stone tools can be produced, I wanted to briefly discuss them in archaeological context by introducing you to the different tool technologies that we know of in the Paleolithic. The first being the Oldowan, which is the oldest stone tool technology. It's also referred to as Mode 1. It's associated with the earliest Lower Paleolithic. There is an additional tool type that it potentially predates the Oldowan, referred to as the Lemequian. However, we will be discussing this later on in the course once we have a better understanding of stone tools themselves. Mode 1 tools are general basic flaked material. So the tool in Oldowan itself is the flake, generally unmodified. The next is the Acheulean. It's referred to also as mode tool, mode 2. It's also a lower Paleolithic tool technology. However, it is more developed than Oldowan mode 1 and generally consists of bifacially worked flaked tools. The Mousterian is associated with the Middle Paleolithic and is also referred to as Mode 3. And this is just a slightly more developed tool than the Acheulean, generally more finely worked and also consisting of more variety in tool type in terms of tool function, as well as levallois, which is the first instance of stone points. The next is the Châtel-Perronian, Aurignacian, and Solutrean, which is mode 4. These are associated with the Upper Paleolithic and generally include very finely worked large stone artifacts. The next is mode 5, Magdalenian. This is also an Upper Paleolithic tool. However, the difference here is that mode 5 and Magdalenian typically includes small blades and bladelet technology. And so as you can see, with each new mode, there are technological advancements, and this is what defines different technologies. So before we finish for this week, we'll go into the Oldowan a little bit, just a brief introduction to what it is, so you can have this in your mind when we go forward with our lectures and understanding of stone tool production and lithic analysis. The Oldowan is the oldest stone tool technology, the easiest to interpret, and thus the one we're discussing today at the beginning of this course. We're only touching on it for now, so be prepared to revisit it in a few weeks once we have a better eye and understanding for stone tools. As mentioned previously, the Oldowan is also known as Mode 1. It's a lower Paleolithic technology spanning from about 2.6 million years ago to 1.7 million years ago, and it's associated with early human ancestors Homo habilis and Homo ergaster. It's widespread throughout Africa and Eurasia. However, it's only found through parts of Asia due to lack of material availability. The name Oldowan itself comes from Olduvai Gorge, which is the site in which the tools were originally identified. It's an lower Paleolithic site in Tanzania, Africa. The tools were discovered by Louis Leakey. You'll probably be familiar with him if you have any knowledge of Paleolithic archaeology. If not, however, we will be talking about him more when we discuss the Oldowan later on. And it was first classified by Mary Leakey. So she was the first really to classify these different stone tools into typology, which we don't necessarily adhere to today. We'll talk about it more when we discuss the Oldowan later on. But the Oldowan itself is a technology that is focused around basic flaking with no additional modification. However, there are different forms of flakes utilized in the Oldowan, and we'll talk about that later. But this has just been, as I mentioned, a very brief introduction to give you a taste as to what lithic analysis really is. Thank you for hanging out until the end and staying with us. I know this was very fast and just a very brief skimming of the surface for what will be the Lithics course. However, you now have a very brief understanding of the history of lithics as well as stone tool production. Next week, we'll continue to build on this when we talk about flake morphology as well as stone tool production in greater detail. We will also be talking about identification and classification of the different lithic components, being flakes, cores, debitage, hammerstones, and so on and so forth. And we will also be going into attributes and the characteristics of lithic artifacts themselves. So again, thank you. I really look forward to continuing this course with you, and I hope to see you next week.